Hello everyone. Today we are presenting our project titled Traffic Light Controller for the course Digital Logic Design. This project focuses on designing a system that can control traffic signal in an organized and efficient way. Next. Team members. This project was completed through teamwork. Each member contributed to different parts such as circuit design, implementation, testing, and documentation. Our combined effort helped us successfully complete the project. Next slide. Problem statement. In many areas, traffic signals operate either manually or with fixed timing. These methods are not always suitable for real traffic conditions, which can lead to an accident. Manual control can also result in error. Therefore, a well-structured system is needed to manage traffic signal properly and continuously. So the objective is, next slide. The objective of this project is to design a traffic light control system that operates without manual involvement. It manages the red, yellow, and green signal for two roads in a proper sequence. Another goal is to understand how digital logic components like timer and counter can be used to build a sequential control system. Done.
Hello, assalamu alaikum. My name is Khondogar Tajul Islam. My ID is 242-15192. I hope you are doing well. I am presenting to a traffic light controller. This system is implemented using simple electronic components where each part has a specific role in generating signals and controlling the sequence. Here, any 555 timer, this acts as our clock generator producing steady pulse that define the timing of the entire circuit. CD407 decade counter, this component receives those pulses and moves through its sequence by activating its outputs one by one, LEDs. These are the visual indicator used to simulate the traffic signals for the roads. Register and capacitor. Register are used to protect the LEDs from our current, while a capacitor are used to control the timing and frequency of the pulses. Diodes, these are used to combine signals from the counter, allowing multiple output to the control the logic of the light's power supply. This runs the circuit, providing the necessary voltage for the component to the function. Go to the next slide, please. Well, now let's look at the circuit diagram to understand the operational flow. The circuit connects a timer with a counter to create sequential control system. How it is work? The process begin with the any 555 timer with produce constant clock pulse. These pulses are sent directly to the clock input of the CD407 decade counter. As the counter receives the each pulse, it activates its outputs one by one in a specific order. These outputs are linked to the diodes, which act as the logic gates for the system. By combining these signals, the circuit determines which traffic light should not be on at given time. Finally, the LEDs turn on and off accordingly, creating continuous and illuminated traffic light sequence. This step effectively simulates a real-world two-way junction with the need of a microcontroller. That's all about my side. My next team member will continue the other part.
Assalamu alaikum. This is Faria Yasmin Mithi and my student ID is 242154663. Now I'd like to explain the working principle of our system. This system is based on sequential logic. Here, the 555 timer works in stable mode and continuously generates clock pulse at a fixed interval. These pulses are then sent to the 4017 decoder counter. With each pulse, the counter shifts its output from on pin to the next starting from Q0. These outputs are connected to LEDs, which represent the traffic lights. As a result, the LEDs turn on and off in a specific sequence. This creates an automatic traffic signal system that controls traffic flow continuously without any manual operation. Next slide. Now my next slide is timing diagram. Now let's look at the timing diagram. This diagram shows how the traffic signal changes over time for roads A and roads B. From 0 to 10 seconds, road A is green, so vehicles can move, while road B is red and stop. From 10 to 12 seconds, road A turns yellow, indicating it is preparing to stop. Then from 12 to 22 seconds, road B becomes green, allowing vehicles to move, while road A remain red. Finally, from 22 to 24 seconds, road B turns yellow, preparing to stop again. This cycle repeats continuously, ensuring smooth traffic flow and reducing the chance of accident. Thank you for your attention. That's all about my side.
Assalamu alaikum. I am Tahsin Ibrahim. My ID is 242-15537. Now I will explain the methodology of this project. First, we designed the NE555 timer in a stable mode to generate continuous clock pulses. Then we connected it to the CD4017 counter to control the sequence. Next, we assigned the outputs to red, yellow, and green LEDs for both rows using diodes for the yellow signal. Finally, we assembled the circuit on a breadboard, powered it, and tested the system to ensure proper operation. Now moving to the limitation. This system uses fixed timing, so it cannot adjust to real traffic condition. It also has no sensors or smart features, making it less efficient in busy situations. Additionally, it is built with basic components, so it is not suitable for real-world large-scale use. Thank you.
Assalamu alaikum, sir. My name is Hasnain Karim. My ID is 2421528. Now I will talk about the calculation. In calculation, our project shows how a two-way traffic light controller can be designed using basic digital logic components. The system works automatically and controls traffic signals in a fixed sequence without any human involvement. This project also helped us understand how sequential circuit like timers and counters are used in real-life systems. Even though our design is simple, it gives a strong basic idea for building more advanced traffic control system in future. Now let's talk about future improvements. Next slide, please. This system can be improved by adding smart features. For example, we can use sensors to detect traffic density and adjust the signal timing automatically. This will make the system more efficient. We can also use a microcontroller like Arduino instead of simple counters. This will make the system more flexible and programmable. Additionally, we can add emergency vehicle detection so that ambulances or fire trucks can get priority. Finally, by using IoT technology, we can monitor and control the system remotely, which will make it more switchable for real-world applications. That was all from us. Thank you for your patience and cooperation.